Hello, in this video we're going to be doing LeetCode problem 202, which is happy number. This is an easy problem, and it states, write an algorithm to determine if a number n is happy. Now, what does that mean? A happy number is a number defined by the following process. Starting with any positive integer, replace the number by the sum of the squares of its digits. We're going to repeat this process until the number equals 1, or the loop endless, or if it loops endlessly in a cycle, which does not include 1. Those numbers for which the process ends in 1 are happy. So true if happy, false if not. So example 1, input equals 19. So we're going to separate the 1 and the 9. So we'll take 1 squared, which is 1, plus 9 squared, which is 81, to get 82. So now we're going to split the 8 and the 2. 8 squared plus 2 squared, 68. So 6 squared plus 8 squared equals 100. 1 squared plus 0 squared equals 1. So this is a happy number. Input equals 2. The output is false, because that never will. 2 squared, which is 4, will never equal 1. So how are we going to code this? Well, let's start by creating a hash set. And we're going to make that an integer. So this will store all the numbers, the results of all the squaring of all the numbers. I'll just call it set and a new hash set. All right. So the first thing we're going to do is add the number that's passed in. And that will determine our while loop here. So we're going to do while n is not equal to 1. So we're going to keep looping through this until we get that 1 value that we're looking for. So we'll start computing the numbers inside n. So we'll store that in result, make that equal to 0. Okay, so now we're going to go through each individual number. So while n is not equal to 0, so result, and this is where we're going to do the computation. So result plus equals the math, and then we're going to do the pow, which is power of n. Now we've got to get, so in the first example we have 19. We need to get the 9. We need to separate the 1 and the 9. So we're going to do mod 10 and take that to the second power. So mod 10, if n is 19 and we do math power n mod 10, we're going to get the 9 first. So then we need to do, to get rid of the 9, we've got to do divide equals 10. And so that'll go through the loop again because n is not equal to 0. And so then we'll go through the 1, do that power, and then n will be 0 in that case. So we'll break out of that 19 loop or whatever, or the while loop there, the first while loop. All right, so once we get that result, we need to place it in the hash set. So while that contains the result, okay, so if the set contains the result, this basically is an endless loop, because if we already have the result in there, means whatever we did to get to that number, we're just going to keep getting that same number because it's already in the set. So we're just going to return false, otherwise we'll end up in an endless loop. Otherwise, we need to add that to the result, or I'm sorry, add this result to the set. And then we need to assign n equal to the result so that we can go through this whole process again through this first while loop up here. All right, and then if we go through all that and we haven't broken out of it yet, we'll just return true. And that should be the entire solution. So let's debug it and see what we get. Okay, so I use the first example, which is 19. So we're going to get a new hash set, and we're going to add the 19. So while n is not equal to 0, it is 19. Result is 0. N is not equal to 0, it's still 19. So we're going to do math power of n mod 10. So we get 81. So we get 9 times 9 is 81. So now we're going to get rid of the 9 on there, and you see now n is just equal to 1. So now we've got, we're going to do n mod 10 to the second power. 1 to the second power will give us 82. And now n is 0. So the set contains result, which it doesn't. We don't have anything in set yet, so we're going to add 82 to the result. I'm sorry, we have 19 in the result, the initial number, but we do not have 82. So now we're going to go through this again with the 82. And 10, so we'll get the 2. 2 times 2 is 4, so that's why we have 4. And then we'll do the 8, which will be 64, so it should give us 68. The set does not contain 68, so we're going to add that to the set. So set now has 19, 68, and 82. And we're going to go through this again with the 68. We're at 64, which is 8 times 8. And then we do the same thing with the 6. So now we have a result of 100. N is 0. Set contains 100. It does not, so we'll add it. And now we'll go through this one more time with 100. Set the result equal to 0. So now we're going to do math power. So 0 squared is 0. Now we'll do it with 10. 0 squared is 0. And now finally we've got this 1. 1 squared is 1. And now we're at 0. Set contains result. It does not, so we'll add it. So now you can see in the set we've got 1, 82, 19, 68, and 100. Now we're going to go up here. N is not equal to 1. That's false. N is equal to 1. And so we're just going to return true. And we are happy. All right, let's run this and see what happens. It was accepted. Now we'll submit it. Faster than 17, memory usage 12. Let's try again. 35 and 50. This definitely is not the fastest solution. I think it's the easiest to understand, but definitely not the fastest. Finally, let's go through the time and space complexity. So we have 2 while loops, so that is big O n or n squared. And then the space complexity is just O of n. Depends on the size of the input parameters. And that is it. So thanks again for watching. Let me know if you have questions, and we'll see you next time.